KB, welcome. And Tom, we'll get you lined up so you could share your presentation here. I'm assuming you have one up there. Is that correct?
I don't know. I should just let you keep talking. This is fun. Well, let's see.
We appreciate you, Tom. Let's see here. Okay. All right.
Okay. Let's see. I have to get on to share screen, right?
Yeah. Greg, does Tom have the ability to share his screen?
Yeah, I made him co-host.
Okay, great.
Ah,
There we
okay.
go. We got
All
it.
right.
We got a presentation.
Be sure to switch to presentation mode, Tom. Just hit
Okay.
F5. Just hit F5.
Oh, F5. Where's 5?
If that's PowerPoint.
1, 2, 3, 4. Well, the PowerPoint's up.
Or just click slideshow.
Slideshow from beginning.
Oh, there we are.
There
Okay.
you go.
Are you seeing just my
Yes.
whatever?
Looks like
Okay.
a Force 12 antenna.
Actually, it is. That shot was taken from our place, our little ranch out there north of town. So I'll have to drive 16 miles to see that, actually 20 miles from this house to see that view again. But here we are tonight. Great, actually, really to hear and see a lot of you fellows again. Of course, I think I work you on the air, but it's nothing like seeing you in person or even on video. So here we are. Now, I mentioned this earlier, it's primarily for limited space and time, not big arrays. However, I think there's some things in here that everyone will find interesting. So limited space, you might have no antennas mandate. I know a few people with that. They do sneaky HOA things, a lot of portable going on. I think Bob already mentioned Summit's on the air, Parks on the air, and so on. Of course, the expeditions are close to my heart. And all those things affect the antenna, which of course is the main thing. And the most common limited space simple antennas are single wires. And Bob also mentioned, sorry, Bob, I have to include you a little bit here. The ARRL is making their own NFIT half-wave antenna. That would bother me if I were an advertiser in QST, but nonetheless. So we're going to focus really on HF. And I have been asked occasionally, maybe not with this group, what antennas I may have used before starting Force 12 back in 91. Doesn't seem like it's that long ago, and which one stood out. So I put together a little list of what I could remember. And the ones that stood out are the ones in red, and the two that are bold are really the ones that stood out. And actually at Visalia this year, Gary Caldwell came up behind me and gave me a big bear hug. I hadn't seen him in I don't know how long. And he made a comment about this particular antenna because we were on Saipan back in '83 and we were able to operate the TCI 611 curtains up on Marpy Cliff. We also had the antenna in the upper left corner, an A3S on about a 20-foot mast overlooking the same 400-foot cliff. And when I first hooked up to one of the curtains, we were on 15 meters, band was dead on the A3S. And Gary said, well, plug the thing in. I said, I'm busy. Well, anyway, I plugged in the big curtain antenna and we switched to it. And Gary said, again in Visalia, he said, that moment is the best moment he's ever had in radio. He said that recalibrated everything. And there was one pile up there. Sorry to belabor this a little bit. I think there's a good bottom line. HZ1AB was on 15 sideband running a big pile up into Europe. And Gary says, call him. And I said, I don't think we have a mic. So finally found a microphone. So I signed my call, N6BT, I think portable AH0. And the operator was Peter. And he comes back and he says, who was that? And I said, sign my call again. And he says, do you know what you just did? Of course, I don't realize what I just did. So he tells me, he says, you just came up over a gigantic European pileup off the back of my antenna. So I said, well, thank you. So he turns his antenna around and we did some antenna checks. And the A3 was an S7 and the curtain was 50/9 on his radio. A friend of ours was on from Guam running, I think, a TH7 and 1500 watts, and he was also an S7. So obviously the hill we were on was helping us, and I was running 100 watts. So we had a little chat about the antennas, and he asked me what I was using. So I told him, and then I said, oh, we have 3 of these, and we're going to be using them in the contest. And I said, oh yeah, we'll get the amplifiers hooked up again later. And anyway, he went on to tell us it was illegal for us to use the antennas. But the difference, whatever room you're in, if you were to black out everything and just be in the pitch black and then suddenly flip on floodlights, that was the difference between those 2 antennas. And since that time, I only found one antenna that I would rank with the performance, and that's a 2x2 vertical array on the beach. And I know some of you have used these before, and they are really a flamethrower. But Vicki and I live right here in Kingman, Arizona, on Route 66, the Mother Road. And our local club here is the Wallapai Amateur Radio Club, WB6RER. And for those of us who are a little bit older, remember, that was actually Andy Devine's call sign. And coming up in September, we have Route 66 on the air. Our club uses the call sign W6F. And if you haven't operated this, it's 9 days, a special event. So we operate work bands also. And there are this year, I think, 23 stations. They all have a 1x1 call sign, W6A through, I think we have the last one, W6W, and there is no W6F. Nonetheless, we're stationed all the way across from Chicago to LA. And there's a fellow from Stockton this year using the call W6V, and he and his wife are driving the entire Route 66 during the 9 days. But if you work all of us, you get a really nice certificate from the Citrus Belt Club in California. So if you hear us on, we're adding a rover, and we're gonna go operate going south, actually to Oatman, which has some unique aspects to it concerning, I'll call them boroughs and be polite. And then we're probably going to go north to Peach Springs and maybe all the way to Seligman, operate in front of the original Roadkill Cafe and who knows what else. But anyway, last year, well, we do this every year. And as I said, it's run 9 days and you can run fairly high rates. So Vicki was on 15 meters one time here, running a good pileup, and that's what her pileup looked like. Nice. Well, problem was, after working through not much, the pileup looked like that. Now, my experience is in DX contests, once I've worked through several layers, that's about what I hear. And what it was, there's just a din of stations. And you can't copy anybody. And the interesting thing was, there were several of our stations that were running that observed exactly the same thing. And so I would hear Vicki talking to her radio saying, can anyone find 2? Actually, I should have her say this when she's online. Can anyone find 2 or even 1 more dB because I could get your call? Well, is she right? That's it. That's really what the margin is to get your call through? Well, yes, she is. Just find 1 or 2 dB and your signal will rise above the rest. Of course, we discovered this starting with Team Vertical back in 1998. Actually, our first trip there was in 97 at the Sunrise and Sunset Villas. And then we went over to the Casita Villa, also in Jamaica. And later on moved over to Eleuthera in the Bahamas. But what we discovered, besides using verticals on the beach and setting all these world records, we would do, the post-contest analysis, and we discovered what I call a gateway to significantly increasing our scores, which was, if we could improve the antenna system by 2 dB, That gave us an entire layer of stations to work, not just a few, but a whole layer of stations. So one more time, is it really that small? So brings up a couple more questions. Who needs it? Station A or Station B? Or does it matter? Of course, is it reciprocal? Does it apply to both of us? So if I'm talking to, who else is here? If I'm talking to Jim, you know, if I go up 1 or 2 dB, does it make the difference? Well, how do we get there? Well, what's an immediate solution? We can turn up the wick. I kind of like that power meter. And of course, that'll get us through the pileup, but I won't hear any better. But what else can we do? Well, we looked at power, location. Unless you're on an expedition, you probably can't change that much, but we can work with the antenna type and the installation. Now, I almost forgot this. My original novice transmitter looked like this, crystal controlled 6AG7 oscillator. Someone else probably had the same rig at some time, and an 807. And my first antenna was the window screen of my bedroom window. Now, you can't do that anymore. Back then they were metal, but today they're plastic or something. Well, then I moved up to a Heathkit rig, the old VF1, which drifted like crazy, and the DX35. I thought I was king of the hill, and an AR3 receiver and a Wyndham antenna, a single wire. Do you notice anything missing from there? This guy. Today we have him look like this. Did anyone care what the SWR was? All you did was you dipped the plate, right, and loaded up some more. As long as it dipped, you were cool. But now today, we have to have the perfect match. So is this the magic improvement? Well, maybe, maybe not. So someone commented on this even before the meeting, my infamous light bulb. And of course, it matched 1-to-1, so it had to have been a killer antenna, right? And yes, I did work 28 countries in one weekend. The other side of that is that was for the ARRL-CW. And then Kenny wanted to do it on phone. I didn't include the slide, but I made a 3-element light bulb for him. It was a phased array, and we ran about 1,000 watts. We put in bigger light bulbs, and he actually worked 34 countries. But after 1 hour, he walked out and said, well, I won't say exactly what he said, but he said he hadn't made one cue yet. And by the way, he blew out all the light bulbs. I think he was running more than 1,000 watts, but it didn't matter. The light bulbs worked just as well, either, you know, intact or not. So, and it did have a balun, by the way. This chart was made primarily with the assistance of Bob Ferrero W6RJ. And it was to show the difference in enjoyment of radio related to your antenna. And so a dipole in the clear is right in the middle, and the backstop was my light bulb. And of course, I arbitrarily, well, not quite arbitrarily, pegged it at minus 18 dB to a full-size dipole. And I actually tested it. I think Dean Straw was at our place, and we tested it to a full-size dipole on 10 meters, and it was about 18 dB down. But can we get 18 dB some other way at HF? Those TCI 611 curtains at the time were about 250,000 a piece, but they were putting out, I think they were rated at, if you did them right, 20 to 22 dBi. But you can do what N7ML did. Mike had actually 290-foot rotating towers, but he put up a stack of 6 C3s all in phase, which calculated at 11.5 dBd. Or Scott back in Rochester, he has a single 130-foot rotating tower with 3 C49 XRs. And that comes out at 13.6 dBd. So obviously, we all know how difficult it is to get that much gain. How else could you get it? Well, of course, we could change modes to FT8. And so if you do that and take my dipole, my light bulb, and compare it to the dipole, that's what I'll have if I'm running FT8. So I have a really inferior antenna, and FT8 brings in a whole new,
Mhm.
let's just say it puts more light on the subject. It allows me to work a lot of stations I couldn't otherwise work. And of course, if I had switched to FT8, I would tell you now that on YouTube how great a light bulb is. But it makes working stations, especially DX, because a lot of the expeditions now are running a lot of FT8, but it does mask poor antenna performance and it limits our enjoyment of radio. I came to realize at a couple of the last conventions that actually, I think it was at Flagstaff, that people that have, let's just call it compromised antennas, they don't realize how much more there is. You know, their depth of knowledge is pretty minimal. So nonetheless, when you're running an FT8 pileup, there will still be a time when you can't get through and you're looking for a couple more dB. So primary concerns for limited space and time. How much space do we have? Do we have trees that we can use? If you're doing parks on the air, can you even put a stake in the ground? In Kingman, you can't do that. What time of day are you operating? You know, if you're going to parks on the air or someone on the air, you probably don't need 80 meters. And what are your target directions? If you're over here, mostly on the West Coast, you probably want to look east. So you want to select your location. Is the area crowded? Vicki and I have operated from a park over in Parker, and it was kind of crowded, but we did get permission from the ranger to set up. And the real key is how much time do you have to operate? Because once you get there, if you have parks on the air or someone's on the air, it took you so long to get there, now you have setup time, then you have operate time, but that's limited by how much time it takes you to disassemble everything, pack it up, and leave. So I already commented on this, pounding stakes in the ground, can you? Also safety, look at your entry points and your exits. CalQSO party, I don't know how many years I ran that, but that was always a very critical thing because you're out there with radio gear. It's very tempting for some people, especially even if you have something simple like a fire extinguisher. Some people might want to take that from you. Look at your potential traffic, both pedestrian and vehicles. And then I learned to position my vehicle aimed towards the exit and always set myself so I see what's coming on. And don't stay there after dark if you're alone. So Vicki asked, I think Tom mentioned this earlier, she did ask what stations they were running. And the answer was always the same. Your antenna was an end-fed half-wave, some single wire antenna. So it's obviously very popular for limited space and limited time. It's really a pretty old design. I'm not sure how old it is, but it's multi-band and low cost. And the focus on everything, if you look at all the ads or if you look at it on YouTube, it's always VSWR. It's all about the match, only the match. And I think that's probably why it's the only thing people can measure. Most people don't recognize the patterns and so on, but they are obviously more important. If you ever come across VU2NSB's website, he has a lot to say on the unfed half-wave. Just to highlight this, he says, many amateur radio operators, I have to read this, tend to believe this antenna can be deployed in any way they want and it will perform well. This is a false notion. Oops. Oh my gosh. Sorry. Hit the wrong key. And then he says, an end-fed half-wave installed in a standard and neat inverted V configuration is far inferior in performance to horizontal, let alone other random orientations, etc. So you can't just toss one up. But the good news is not all manufacturers only talk about the match. Actually, DX Engineering has one, the packed end-fed half-wave, and they do tell you. They say it performs similarly to a half-wave dipole. This is their long one on 80, radiating best broadside. And then as you go up in frequency, they tell you creates multiple lobes at angles closer to the line of the antenna. So it's actually changing direction. then, of course, they tell you that as long as the impedance is suitably high, you get a good enough SWR because of the un-un. So if we look at an end-fed half wave and another single wire that you see a lot of, the off-center fed dipole, what do they have in common? Feed points unbalanced, the antenna is long on the high bands, and it needs a counterpoise, at least a very short one, and coax ends up being part of the antenna because normally there is no balun. So how do you improve one? Okay, nice drawing. A practical one. What do we have? We'll put them side by side. So the counterpoise is short enough for the highest band. There's 0.05 wavelengths and long enough for the lowest band. So they both have that. They both have an un-un. You all know what that is, right? Unmatched to unmatched, it is not a balun. It only does an impedance transformation, which means the coax is not isolated and the shield of the coax is now part of the antenna. So possible locations for loss. If you don't have the right material in your un-un, you can lose up to 4 dB. That's a ton. And you obviously can have more loss in the coax due to a high VSWR. And you have really a subpar performing antenna. So let's run an experiment. I did this back in October using the reverse beacon network on 20 CW. I used this antenna, which is a full-size 20-meter vertical with an open ring current return. That was a prototype. Project was called Viper, and the ring is only 12 inches off the ground. So you've got the vertical here. Actually, this was a 3-bander, 2015 and 10. And this is the open ring here with 3 consecutive open rings. So first I ran 5 watts. Oh, this was during CWT, so maybe the skimmers were busy. I don't know if Bob heard me or not, but anyway. So on 5 watts, I transmitted for 45 seconds. 5 watts, I got 15 spots. 50 watts, I had 25 watts. Increase of 10 dB, right? So now if you look at the comparison on the spots that work the same for both, the one that really doesn't quite match is KL7RA. I'm not sure why that was, but all the rest are fairly good. So difference between 5 and 10 and 50 watts, 10 dB, almost doubled the number of spots. Single wire, what do they look like? I already mentioned this before. And if you orient the antenna correctly, you can improve your signal. So looking at azimuth patterns, and I hope everyone on here has looked at a lot of patterns before. I have a feeling you have. So we'll use an end-fed half wave, 60 feet long. We'll slope from 2 to 20 feet. And we're just going to take a slice at 30 degrees, 40 through 10 meters. So the antenna is actually going this way, but the pattern is going the other way. So if you put this antenna up aimed at the East Coast, you're going to do good to Hawaii. So now you go to 20 meters, signal looks like that. You actually have max signal in 3 different directions. And as you move up through the bands, the black is 40. Then we have 20, 15, and 10. And your pattern is always changing. So let's make it twice as long because we have to get to 80 meters, right? But let's raise the end a little bit because wire antennas need to have height. So now we're going up to 30 feet. We're going from 2 feet to 30 feet. So now on 80 meters, our pattern looks like this. We've seen this before. 40 meters now looks like that, and so on. If we compare the two, we have a 60-foot long one here and the 120-foot long one here. And really all that we did was we moved the patterns down 1 band. So the moral of this is, if you're doing parks on the air and you only need 20 through 10, don't put up a 120-foot wire. Besides, that's really hard to do in a park. You know, pick the right length antenna to get your lobes where you want them to go. All right. So let's make it into an inverted V at 30 feet. Feed it at the top center. hey, 80 meters looks great. It looks just like a vertical. So that may be an improvement. 40 meters looks like that compared to the NFET half wave. Now we're on the higher bands. I don't know, it's a mixed bag, except when you get on the highest band. Well, enough of the patterns. So, thought for the day, SWR, because it matches, only means it matches. That's all. So if we're looking for some kind of improvement, first of all, an NFET half wave is an efficient antenna because it's copper wire. And the patterns depend on the height, on the length of the antenna, the height, and the band you're on. So matching it just keeps the transmitter happy, does nothing to provide information on where your energy is going. Well, how can we get a more uniform pattern then? Well, it's pretty easy. There was an article that Ward did earlier this year called The Magic Carpet. It's on this online thing called On All Bands. And he's talking about operating portable, and it's talking about verticals and other horizontal things, wire antennas, transmitting loops. And then he finally says that the performance can be very disappointing. So he comes up with a solution. And this is called the Magic Carpet. And it's 3 10-foot rolls of hardware cloth serving as a ground spring. The catch is he changed the antenna to a quarter wave vertical instead of the NFET half wave. So what other components can contribute to loss in any antenna? Well, let's test one. Now I know Vicky is online. And by the way, that's one of the drones. That was drone number 2. I crashed number 1. I also crashed number 2. And now we have number 3. Also, Vicky got that one for me. That's a big ouch. Now, I started doing this at the Zion convention, and Vicky was way in the back of the room. And she says, "Excuse me," like nobody knew who she was. And she said, "Will you please tell who the manufacturer is of this antenna?" Because she actually is the one that owned it and bought it. So this is a buddy pole, and we first set it up on 15 meters. So, it's probably about 3/4 full size, and it has some coils and these really pretty shiny telescoping chrome tips. So then all we did, we tested that one, and then we made some aluminum tips and screwed them in the same place the telescoping chrome tips went. Anyone want to take a guess as to what the difference was? Somebody hold up some fingers. No.
2 dB.
3 dB. Yes, just by changing these telescoping chrome tips for aluminum. So then we set it up on 40. And we made them the same size, equal height radiators. Of course, the buddy pole has the same coil. I have air core coils. The antenna I was using was basically one of my Bravo designs. So we're both coil loaded. They have theirs a little higher up, mine's at the base. And we dutifully put up their 31-foot long copper radial. We were using for the current return these short aluminum radials that I call resonators. They're also loaded. And we have a hairpin match. They both matched at 2-to-1. And to make sure we did it right, Vicky actually called the company and talked to the president and followed all of his instructions. They both matched, as I mentioned, at 1-to-1. We flew the drone through the pattern at 2 wavelengths out, and we flew it through 4 times. I think there were 6 people there watching, and you might wonder why we did 4 trips. It's because no one believed what the result was. So anyone got a guess on the difference here? Okay. Well, it was a 12 dB. Pretty amazing. Now you get a clue. I've been trying to figure out how you can get 12 dB, except there's no impedance transformer on the buddy pole. So it should have a feed point of less than 15 ohms, but it matches great at 50. So that's about 35 ohms of loss, or you're down a little over 5 dB just from that. Then if you add in some other things, you can probably get to 12, but it's really pretty amazing. So what not to use? Do not use stainless steel for a radiating element, anything, or anything but a screw, meaning a mechanical component. Years ago, the original K6KM, I put a 3-element 40 up at his place, and I asked him if I could put in a stainless steel hairpin match. And I asked him if he'd run it for a month, just make notes, and then I'll go up and change it. Well, that was about a 300-mile drive to get to his place. And he called me after, I think, 4 days and said the antenna is a piece of wood. So I drove up there and swapped it out. And the difference, of course, is right here. This gives you a clue. And if you make a coil out of copper that has an unloaded Q of about 600 or more, if you make it out of stainless steel, it's less than a Q of 30. More on stainless steel. We also tested a 5/8 wave stainless 2-meter whip and a commercial unit. And I took some tin braid and first of all, put it over the whole thing. And I picked up almost 2 dB. Now we're testing this using our calibrated signal source and our portable spectrum analyzer. So then I said, well, let's do what I called a half braid over. So I had half braid just on the bottom half, about 1.5 dB improvement. And if I only did 1/3, it was about 3/4 of a dB. So a nice trade-off. We've actually had a couple of guys in our local radio club do this in real life, and they can't believe what the difference is. One of them, we have our club repeater, and there were a lot of holes around town, and he did this to his mag mount, goes everywhere, he's full quieting. He said he can't believe what the difference is. But you can also do this at HF, because most mobile antennas have a big 102-inch stainless whip. So I got an email from W7RF Radio Dan not too long ago saying that they decided to take me up on my challenge, so to speak, on his. And then he had a friend of his, Dave W8XAL, do the same thing. And they finally set up a test where they would swap one and the other just immediately. They'd screw one in, test it, and do it the other. He said they couldn't believe what the difference was. Unbelievably different. So I did some more research, and this guy came out in the market, I think in April, called the Big Kansas Coil. I don't know if anyone's seen this, but very popular, obviously, for parks on the Air Summits. And it looks like this. Very, very clever mechanical design. A little tripod here for it, more parts. And if you read everything, it's interesting. The fellow that's really plugging this is this fellow does a lot of YouTube. And this is what it looks like. Now, if you look at their data, let's look at some SWR curves. 20 meters, gorgeous, 1-to-1. There's no impedance transformer. Feed impedance should be less than 12 ohms. 40 meters, gorgeous, 1-to-1. Should be less than 5 ohms. So what's the deal? Well, if you look at their data, it's manufactured, it's actually 3D printed, and they use carbon fiber filled nylon. Now, I'm not sure why someone would pick carbon fiber filled nylon for a coil core, but they do. So they not only have carbon fiber filled nylon, but then they wind the coil with stainless steel wire. They do give you 3 33-foot lengths of copper wire for radials, but nonetheless, if you wanted to make the worst loading coil, that's what you would make. So I decided to do a little calculation here, and I was calculating 2 loading coils, 3-inch diameter, 25 turns, and you need 235 inches of wire. Resistivity of copper is this. Stainless steel is that. That's a pretty good clue. Resistance in both are those numbers. And then I made a model of my Bravo vertical and plugged one coil in, one in the other, used the constant reactance, but changed the resistance. And it looks like this. So there are the resonators. And the pattern showed for the copper coil, 6.3 dBi, stainless steel, 2.7. Not a good deal at all. And of course, that did not include any loss from the core material, if you were to make it like theirs. Okay. Why am I not progressing? There we are. So just one more look, and that's a good thing to remember. Stainless steel anywhere except for, some kind of a connection, not a good thing. So as I mentioned, if you want to make the highest loss coil, make it just like this. Well, they also give you a clue. It's rated, let me back up. It's rated 100-watt digital at 50% duty cycle. That's another clue that there's a lot of heat generated. Now, if anyone has a truck, like our Dodge, we have an AM antenna that looks like this. It's called a wind noise cancellation wire wrap. You get this, I'm not sure if it's connected to anything, but it has, of course, spring steel construction, and it supposedly keeps the wind noise down. Our truck's so loud, I can't tell the difference. But if you do the same thing on your HF mobile whip, you will have a wind noise cancellation wire wrap. So you use copper wire, put it on there. You still get the spring steel construction, and it's a double win for you because it still works the same way in the wind, but now you have a real conductor. We also were doing some testing with this little guy from Ellicraft. Comes with a 45-inch base-loaded BNC connector with the telescoping telescoping antenna, again, the nice chrome one. And we were trying to come up with some data, and we really couldn't figure it out. So Glenn said, why don't we try to do something that we can track? So we decided to see where the resonant frequency was with the 45-inch telescoping chrome part, and that's the red one. Then we made a copper wire and got it on the same frequency, very close, and that was the trace. So the difference is the chrome was 45 inches long, the copper wire is 55. So 22 inches longer, velocity of propagation in there is probably a clue. I came across this picture or video, I just took a screenshot. So this is the Franken antenna. I think that's how he pronounced it. And what does he have? He has this new gigantic, I think it's a 25-foot telescoping chrome whip. And for $100, you can get one. Of course, I have a good idea how much loss it has. So the better deal is to use a 7-meter long or however long you want telescoping fiberglass pole and put some copper wire on it, and you'll be way ahead of the game. Also, there's a lot of coax I've seen, and be careful when it says something like this, RG8X type. Be very careful. So anyway, we looked at a few components and varying patterns. So let's try to distill something here. Everything works, but works better than what? When we look at all the patterns, we expect the antenna to perform like the plots, right? It should do that. Well, but what if the antenna is not all alone? Because to operate as we expect, it has to be in the clear, from other objects, buildings, and so on, and other antennas. How far away? Ward Silver came up with this a few years ago. We were talking about this. He called it the standoff distance. And that distance really is about a quarter wavelength minimum, because you can build a Yagi with quarter wavelength spacings and it works just great. Their catch is it's a sphere. It's not just in two planes. So what happens when we put up an antenna and we have an object somewhere in our standoff distance, what does our pattern actually look like? Well, it looks like the physical antenna we put up plus everything else within its distance, and we might have an alien antenna. So it's also a two-way street, of course, works both transmit and receive. And generally speaking, less antennas is usually better. I'm not sure why I watched this video 3 times, but I did. It's a European who has a very nice hex beam and an end-fed half wave. And he put it up. And this is the end-fed half wave. And here's the fly lead going to the on. And of course, the hex beam is right above it. And this end-fed half wave is 60 feet long. So I decided to plot it and see what it's got. First of all, to get the right model for the hex beam is kind of tricky, but you can find it. And so then I added the end-fed half wave. The hex beam alone has a pattern looks like this, nice elevation plot, 9.22 dBi. The way he had it oriented, he was a little bit off, so I rotated the model even. So that's what the hex beam looks like, you know, from the bird's eye view. All right, so let's feed the hex beam with the end-fed half wave. This is the clue you get right here. I'm showing the currents. So even though it's exciting the hex beam, the end-fed half wave has a lot of current in it. And those are the patterns. So that's the hex beam alone. And that's with the end-fed half wave underneath it. The gain that you lose by doing that is, well, he now only has 7.59. So he's lost about 25% or a third of the gain of the antenna by putting the end-fed half wave there. But that's actually 50%, sorry. But the worst part is this. When you feed the end-fed half wave with the X beam up above, you also get distorted patterns. That's the end-fed half wave on 20. And that's overlaid with the hex beam. So he's doing all these antenna comparisons, A, B, you know, antenna A, antenna B. How do you tell which it is? To me, it's a toss-up. So I then rotated everything 90 degrees, one to the other. Patterns were still terrible because the bottom line is he does not have 2 antennas up there. He actually has 1 antenna with 2 feed lines because you can't run one without the other one participating in the pattern. So if your goals are efficiency and a predictable pattern, what do? End-fed half wave, I already mentioned, shorten the wire. Make sure you have the right on so you don't lose there. Little short counterpoise. If you really want the best efficiency in L match, although that makes it a single band, and add a ball in there to get the coax out of the circuit. And also elevate the single wire antenna, whatever kind it is, because horizontal wire antennas want height. And aim them for the right target. If your on gets hot, obviously it's very inefficient. So other options, you can use a quarter-wave vertical, like Ward did. You can use elevated radials of various kinds. You can use short and loaded ones like we do on the Bravo series. And if you're doing portable, you can use a really good vertical, the DX Commander out of the UK, our old ZR designs or the Bravo or Sigma series, and use a fixed length vertical with a good current return, air core inductors. And of course, a simple vertical, it's lightweight, you can set up for each band or use a tuner for 1 octave, and it's pretty high efficient. And it has a predictable pattern, the classic donut. And some of the research we've done going back to 2014, if you use a vertical adjacent to sloping ground, for each degree of slope, it will lower your takeoff angle or launch angle 1.1 degree. So typical quarter wave vertical, tune the radials beforehand. There's a good technique for doing that without going through all this. You guys probably know this. The real key with the verticals, no ground contact. Let me digress for 20 seconds. If you take this antenna right here and put this, lay it on the ground, just the classic vertical like we all learned way back whenever it was, and then you take and elevate that antenna with the radials off the ground, you will improve by almost 7 dB. And tuner at the rig, okay, if you have relatively short feed lines, but sloping ground is a great asset. D-Expeditions, some of you probably saw these this stuff from Kenny. Already mentioned that they had some additional problems here, such as foot traffic. And so we're down in the British Virgin Islands there. Nice place. And of course, they had a reef out there, hopefully to minimize the wave action. North America, Asia is that way, Europe's that way, South America is back toward me. Nice beach, except of course, it was public. Plus it had 2 bars right nearby, and apparently people would imbibe a little too much. But anyway, so the only solution was really to use this Viper design. And I built 7 of these. That's what the model looks like. It's actually a little taller than a quarter wave, and the current return is this open ring right here. And the open ring is just a bit longer physically than a quarter wavelength. Feed point looks like this. You can feed it directly. And the 2-element array, we did use hairpin match. So they used the 2-element headed toward Asia and North America. Used the open ring there, fiberglass base post. It's called a thing called a sand spike. I'll be okay. And of course, all the coax had to be buried. The 2x2, the big flamethrower to Europe, was this guy. And as I mentioned earlier, each antenna was only about 3.5 pounds, including the 4-foot fiberglass base post. And the other thing I did, I made an inductor box they could put on the spare antenna, which was number 7, which allowed them to cover all the way down to 20 meters. Although what Kenny confessed to, so to speak, they just used the rig, the tuner in the rig, and worked, I think they're working China and a lot of other things on 20. So optimizing the antenna, for example, this is where their 2x2 was aimed. Their 2-element was off, headed this way. And gain-wise, a single, about 6.8 dBi. This is all for saltwater. 2-element, almost 11, and the 2x2, almost 16 dBi. And of course, congratulations to them for setting a new record, and they're headed back again this December. Maybe the ultimate is the rig in a box. If you worked Ducey, one of their test islands was this place here, down in French Polynesia, and they're using verticals on the beach. There's 1, 2, 3 there. And right now Jarvis is on the air, and they're using my original V8s that I made for them. They also have a V9, a little taller, and then they run a what they call a V10 and a V11. So all using verticals on the beach and so on. The Bravo design, I found a couple old pictures here. This was from 2010 on Eleuthera, the first one we ever did. That's actually a 40 meter. And I'm being scrutinized carefully there by Walt and Kenny. But we had no space for bell-wing radials or anything else. So we really had a very difficult time finding something that would work. And this design has turned out to be really excellent. So for multi-band operation, there are base loading coils. You can put them in the vertical and also in the resonators. The ones I made for a rig in a box, I renamed the DX8. They were mechanically built a little differently for their transport, but the 19-foot radiator and the resonators were adjustable depending on what tuner they were running. So word of caution, I'm sure you guys know this. Be careful where the high voltage is on your antennas. Way back in Minnesota, I ignited my roof twice when we had a wire break. actually an insulator break, and it landed on our shingle roof. And please continue to think out of the box. I'm not sure who thought this one up, but that was pretty clever. And we're all getting older, so the future of amateur radio is really the youth. So I appreciate all your time. And if you have any questions, Vicky will be glad to answer them.
Great job, Tom. Thank you.
Yeah, thank you very much. Very nice.
That was fantastic, Tom. Thank you so much.
Yep.
It's great to see you.
Hey, Tom, Gary, N6BT. I've owned 2 of your antennas, a Bravo and a custom-made 1517-20. I had in my little HOA backyard. And quick question for you. Tell me about the relative performance of one of the verticals where the essentially you're using the salt water itself as as the radial field. I see that where the sort of like just lower your elevated radials till they're in the water. How does that compare with that antenna if you use one of your conventional elevated radial versions?
Okay, we've actually tested this real life. We tested it out in Los Osos. There's a bay there that says salt water. So we actually set it up, and we did all 3. We had actually vertical on the beach, and we went out in the ocean, set up a big aluminum plate on the bottom of the ocean on the sand, and then we replaced that with 2 resonators. And the right answer is, if you, like on the their V10 and V11, where they're using the ocean for the current return, if you instead put 2 resonators, even if they're loaded above the water, you pick up 7 dB. And then we also did the other thing where we had the vertical right on the beach, and you throw a wire out there into the ocean. We put a big bolt on it, so it was right on the bottom. If you do that, instead of having 2 elevated radials on the beach, 15 dB.
Tom, does that what you just described with the resonators above the water, does that model? Do you see that if you model it?
Well, the catch is modeling the saltwater so-called current return. The part that people forget is that salt water is really not a very good conductor. You put it on the bottom of the ocean, the skin depth, I think, is only like 3 or 4 inches. So it's an untuned, it's just like putting a bunch of radials on the ground. That's very inefficient also. It's untuned. So you still want to tune current return. And the key is you want the current to be, max current to be in the vertical and not in the somewhere else in the ground. So I think if you use some very sophisticated software like Steve Stearns has, you probably could model it. I have some new software called Ansoff. I think it's out of Chile, and I might be able to do it with that if I spend enough time. But we flew the drone through it enough. The fellow that was helping me, the water was like 52 degrees out there, and he said, "If you want to keep doing it again, be my guest. I'll fly the drone." So
Tom, you said something was 15 dB, but I didn't quite understand. Did you say you've got a vertical and you've got an insulator for the driven part, and below the insulator is like a tube that's touching the salt water, and then you throw a wire from that tube and you get 15 dB of gain or 15 dB of loss? I didn't quite get it.
Well, there is no gain on a single element, so it's all loss. So let me go through. So the classic thing I've seen a lot of people do, they have a vertical on the beach, right by the surf. Then they take a random wire and throw it out in the ocean. If you replace that with 2 resonators, like on a Bravo, about 15 dB improvement. If you put the antenna out in the water, and for your current return, you have aluminum tube or something going down to the bottom of the ocean, and you replace that with 2 resonators above the water, a 7 dB improvement.
Okay. So basically, like we use the gull wings right near the
Yes.
salt water, not touching the water.
Right. You don't want,
Copper
want
returns
ground-
current better than salt water.
yeah, the bottom line is you don't want ground contact.
Right. So salt water is a
course-
great reflector, but it's not a great conductor.
Yes, that's exactly right.
So,
And of
so
course,
Tom,
well,
sorry.
you do want the radials a certain height above the water if at all possible. And we've got a chart that, or above dirt or above water. And we have a chart that tells you how high they should be.
So the message here then is that salt water should be treated just like ground, just like earth.
Yes, except it's a great reflecting plane.
Yeah.
So
Tom-
on top of a mountain, Tom, we've learned several absolutes. One of them is we had a full-size 160 meter vertical made out of Roan 25, and we didn't get it to really start working until we had 72 radials down. So if you're considering a ground-mounted vertical, you got to put the radials down. So we changed that. Having high towers, we have two 160 ground planes in phase with 4 radials each. And that's a killer. Getting the radials, the feed point's 10 feet off the ground, and the radials do not touch the ground. And that's what you need to do if you're gonna do something with if you have the room and the height to put up ground planes.
Well, the antenna I used, I currently still hold a couple world records. One's on 160. I hold the world QRP record in the CQ Worldwide. And that antenna was 54 feet high with, I think, 4 top radials. Then we had 2 elevated radials. And I can't recall, I think I made 760 Qs in 64 countries and don't remember how many zones, but it's around 126, 130,000 points running 5 watts. So elevated radials definitely work. And that one of the reasons why that worked so well was that I was 45 feet above the ocean to the 2 eastern quadrants, and the other way it was about a 10-degree slope for 2 miles back to the Caribbean Sea.
Tom, what would you?
There was another situation where I talked to you, probably 10, 15 years ago about elevated radials, Tom, for 160. And I'd started out with 6 feet based on some work that, I've forgotten his call, had done. The guy who's done the really good stuff on grounding and radials. And I found it didn't work. And I talked to you and you said, get up to at least 16 or 18 feet. And I did that and it started working.
Yeah.
My 160 verticals using gull wing feed are 16 feet above ground. 2 radials on each of the 4 elements.
Are the
Right now-
radials 130 feet long each?
Yeah, roughly.
Mhm.
In fact, I tune the array or tune each vertical by adjusting the radials.
Yeah, I did the same
Yes.
thing for length.
Yeah, you just fix roughly a quarter wave on the vertical itself.
Kenny just posted something in the chat about material conductivity. Copper.
Yeah, it didn't post well.
Yeah.
But basically, the difference between the conductivity between copper and salt water is about 10 million times.
Wow.
Yeah,
And,
So
and also,
what-
that's a DC. I don't
yeah,
know. Does it make a difference at AC? But interesting.
What antenna is N5J using on 160, Tom? Do you know?
Yes,
of
they're
your-
using they call it V11. I had it on the slide there. If you go to their website, they have a picture of it.
So
And they're using the salt water for the current return, so they could pick up another 7 dB or so if they wanted to use some radials above water
I can say it really works. They were S8 using a single vertical. I worked them with 50 watts.
Yeah.
On first call.
Hey, Tom.
Yes.
Quick question. I'm just curious how. So I've been on a couple of traditional DXpeditions. You know, the ones where we get in a boat and actually go there and we set up antennas. And most of those we used vertical dipole arrays. And I noticed that you're not showing those here, but more your Bravo designs and stuff like that. How did those traditional VDAs compare to some of your designs?
Well, the VDA, the vertical, well, actually, the original was called an SVDA, switchable vertical dipole array, and I did that for Kingman Reef. Oh, I just forgot his call. He passed away like a year ago. Yeah. Anyway, he called me up and he said he wanted some verticals that it could switch directions because they're on this little place and they needed to go both ways. And they didn't want to have any radials of any kind. So we built the switchable vertical dipole array, which was a true vertical dipole. And then at the base, there was a mechanical switch, just a little jumper that would change the parasitic element from a reflector to a director and change the direction of the array. We use those several times in Jamaica, and they work really well. They're just much taller and more difficult to erect. That's all.
Got it.
Oh, I should make a comment on the vertical open ring like I made for Kenny's group. We did a lot of empirical testing, and a single open ring is within 1/100th of a dB, as best as I can tell on our analyzer, to 16 tuned radials. Actually, I think it did 32. And those
was the ring made of?
Those radials were on the ground, and they're actually tuned correctly. They're about 30% shorter than quarter wavelengths. So it's virtually identical to a pair of elevated gull wing types.
Tom, a couple questions. The loop at the bottom there, it looked like it was standoff with fiberglass and an X-brace, but was it made out of coax like RG8? I couldn't quite see the material you were using for that.
It was stranded wire.
It was a like number 14 stranded wire to make the loop?
Number 16.
Okay, so it's not a thick wire. Okay.
No, on all the antennas that were at our place out at the ranch, well, we had a 2-element 160, and I used open rings for that. They were 13 feet. They should have been a bit higher, but I did a little trick to get a little more bandwidth. I ran parallel wires. They were number 14 copper, but I spaced them 6 inches apart and connected them, so it kind of simulated a bigger conductor. I got a little more bandwidth.
So kind of on those lines, as you know, I have a shunt fed tower on 160, so it's steel, it's galvanized, it's crank up, but it doesn't seem to vary much on SWR when the wind blows. It's pretty big, as you know, but of course it's ground mounted and grounded. And just so I, threw some short radials into the lawn, and I'm wondering how could I improve things if I were to run like N6KT thinks that he should change the vertical radiator up from a tower section at PJ4K to a copper wire parallel to the mast. I don't know that he thinks he'll get some gain out of that, but of course you've got the two wires touching each other and when they come together at the top. So basically, would hardware cloth work better in my situation, and would running a copper wire all the way to the top of the tower see any difference versus, nice fat tower to load up?
If I were at your place,
you're welcome anytime.
what I would do, I would try to figure out how to make an open ring. It does not have to be symmetrical. You can model this. I also do offset ones where the ring actually is off to one side of the vertical.
How long does it have to be on 160?
You can load it.
Okay.
So it can be much shorter. I have some pretty good models. I'll spend a little time and do a couple for you.
Thanks.
By the way, Rob Sherwood published that hardware cloth idea in, boy, what was it? it's one of the old radio magazines that doesn't exist anymore in about 1975 or 80. And he was doing something. He just ran this hardware cloth down a driveway. That's where he could put it.
Well,
but Tom, what about the vertical copper wire? I don't think you got to that.
Oh, okay. First, a little comment on Ward's thing there with 3 rolls of this mesh. I can't imagine doing a summits on the air, schlepping that up to a summit. But a copper wire, well, your tower is galvanized steel, so the conductivity of zinc, not that great, not super bad. The steel obviously is, so might be an interesting experiment.
No prediction?
I think it would do a little bit better.
Okay.
But it's getting it set up so it doesn't move around.
Yeah.
Tom,
mechanically.
Yeah, so
go
Tom,
ahead, Bob. Tom, you got me thinking about the open rings. Instead of the 4 radials, which are constantly falling down, would putting a open ring at the feed point do the trick for a counterpoise?
Yes, that's what I used. I supported the open rings using some pressurized 4x4 posts. And so the square is approximately 34 feet on a side. That's all the space it takes.
Would you send me a drawing of what it would look like on 160?
Sure.
Thank you, sir.
So Tom, you have me rethinking. I have your Tornado 8040.
Yes.
It's not the flagpole version, it's tapered version. Right now I have it on the ground. I have 64 33-foot radials about 2 inches into the ground, so the mower doesn't catch them. And now you got me rethinking that perhaps I should change that and either use one of those rings or put the base up higher and elevate the radials.
Either way, you'll come out ahead.
Yeah. So
Well,
I'd be interested.
Let me give you an example. I mentioned the classic vertical, like when I was first licensed, quarter wave vertical, quarter wave radials. If you actually build that, using the formulas, and you look and see where it's resonant per 20, it'll probably be somewhere around 12 megahertz, maybe even lower. And then you think, oh, I've got something wrong. So what do? Well, classically, you're going to lower the vertical. You're going to shorten it to move the so-called resonant point up. Well, that's the opposite of what you really should do, because the radials at a quarter wavelength are way too long, so your maximum current is in the dirt. So now if you lower the vertical some more to move it up to 20 meters, you put more of your maximum current in the dirt. So when we were doing this, when I was younger, we were doing it all backwards.
They should have shortened the radials.
Yes.
Yeah, what I did an experiment just for myself by measuring finding the resonance of a dipole laying on the ground as I raised it, and what I found was the velocity factor was exactly what you said, Tom. It's about 30% less.
And rising stars. Northern California's premier casino resort is the perfect place.
We're hearing somebody's ad there.
Sid's iPad there. Wherever Sid's iPad is needs to be muted by the host.
No broadcasting.
Oh, power.
Hi, Sid.
So did my comment get through?
Yes, it did. I could hear you through the QRM. I used artificial intelligence to fill in the blanks.
Oh,
Artificial is getting to be what little I got left.
Well, thanks again, Tom. Well,
Yeah,
Tom?
and feel free to send me an email. I know Vicky will say to send it to her instead.
If you want to get through to him, my email's the best.
the one on QRZ.
Yeah. It's real simple, N6KOS@yahoo.com. Tom, why don't you, it might be of interest to the group. We just are putting a tower up, and how we put the cage in.
Oh, well, the base plate is it's a very small tower. It's a heavy duty 2-section US tower. But the base plate requires 1-inch J bolts or ground anchors. So it's pretty heavy. And then I made this real heavy cage, welded it all together, and it was probably about 150 pounds. I don't know, maybe a little more. So the question was, how do we get that in the hole? And I said,
More importantly, Tom, how do the two of us get into the hole?
well, I figured Vicky would just pick it up, throw it in the hole.
You need an engine hoist.
Well, so what we did, we have a lot of parts, and so I made a winch. I took a fairly long piece of 2-inch thick wall aluminum square, put a winch on it, put it on the rack of the big Dodge truck. It's a diesel 3/4 ton. And it went from the back of the rack underneath the next one. Then I had a winch and a pulley and just made our own little crane and winched it up. And of course I had to back the truck up a little bit and not run over Vicky. But anyway, and then I got back there and lowered it, and she's guiding it with a hook and got it in place.
What's your tower going to be?
It's only a 2-section crank up with a fairly tall mast. So right now the antennas, well, we've got an urban beam, which is a nice little thing, but I'm probably going to put a stack for 10 and 15. I have some dual banders, 10 and 15 meter dual banders that we had on another test tower. And so one goes above it and one goes below it. Then we got some other stuff. We have a big magnetic loop for 80 through 20, although we have a lot of local weird noise. Don't know where it comes from.
Before the presentation started, you mentioned that your ranch was for sale. Is that right? Have you moved your location again?
Yes. Yeah. We now have a house on the ranch was just past the 16-mile marker north of town. Now we're about 4 miles on the south side of town in a pretty much residential area. And yeah, the ranch went on the market, I think 3 weeks ago. We actually moved in December, but it took a lot of time because I had to take down 4 towers and 13 other antennas. Oh, we had about 3,000 feet of buried coax. So if someone needs coax, let me know.
Tom, could I ask you a question? K6ELE.
Sure.
I'm running your 3 CSS on a 31-foot tower, and I want to put up a 6-meter 2-element beam. Should it go above your 3 CSS or below it?
Above.
Okay. Same direction?
Yes. By the way, that's a very interesting photo.
Thank you. That's from my last trip to Egypt.
Well, Vicky should say something to you.
Yeah, I was just looking at that photo. I have similar photos. I've been to Egypt before. I'm going to Egypt in December. My son-in-law is from Egypt. So pretty exciting trip. Looking forward to it, but it's a beautiful photo.
Well, you'll love it. It's a great experience.
Yes, I've been there once before. So I'm looking forward to the second trip.
Well, good luck. Thank you, Tom.
Sure.
This is for Ken, by the way. This is for N6RO. That's the 160 antenna on Jarvis.
Ah, okay.
There it is, and complete with all the bird abatement.
Yes. Wow.
That was just sent out by Don a little while ago.
Okay.
Yeah, Tom, I'd like to share something with you that Steve Stearns did. He modeled the the dense redwood forest for my 160 meter second antenna, and came up with a loss of 7 dB loss from the trees.
Yep.
I subsequently, without having seen his test yet, did a very extensive RBN study, and using a lot of stations and plotting them a number of times over a bunch of days, and all the multiple averaging things. And when I did that, I came up with 7 dB.
Yeah, he's got some very good software. And by the way, he also modeled the vertical adjacent to sloping ground that actually validated our drone data.
Yeah, that's awfully important work you did, Tom.
Oh, I think you need a bigger amplifier.
All right, well, we'll leave the bridge open for a while for people to socialize, as long as Greg is willing to keep the meeting open. Otherwise, we'll bring this one to a close. 50 attendees for most of this, so that's great. It's been a while since we've had that.
I forgot one thing.
Yeah, go ahead, Tom.
I forgot one thing. Route 66 this year is actually the 25th anniversary since they started doing Route 66 on the air. So
Wow.
there should be a lot of activity. And also, if you like Route 66, in 2 years, it will be the 100th anniversary of the actual highway.
Got
And
some
if you
special
want to come,
certificates to come out.
and if you want to come and operate, just let us know. We're looking for operators, good ones.